Okay, so this is my videotape discussion on stoichiometry. So the two formulas that were given is that 2Na3, which is sodium azide, decomposes to give you 2Na plus 3N2, which is sodium and nitrogen. The second formula is 10Na, which is sodium, plus 2KNO3, which is potassium nitrate, reacts to give you K2O, potassium oxide, plus 5Na2O, which is sodium oxide, plus N2 plus heat, nitrogen and heat. The first question asks, how many moles of potassium nitrate must be included in the reaction mixture to consume the sodium produced by the decomposition of 1 mole of sodium azide? So what this is basically asking you is if one mole of sodium azide decomposes, how much nitrogen is going to be, how much KNO3 here is going to need it to decompose the nitrogen that is produced by this. So pretty much not the nitrogen, the sodium, I'm sorry. So pretty much Na3 is going to decompose to give you sodium. So the sodium from this is going to, the reactant here is going to go into the product. I'm sorry, I got that mixed up. The product here is going to go into the reactant here. So KNO3 is going to react with sodium. So the first thing you're going to do is you're going to set up a mole ratio to find out how many moles of Na will be produced if 1 mole of Na3 decomposes. So you're going to do 1 mole of Na3 times 2 moles of Na over 2 moles of Na3, which gives you 1 mole of Na as your reactant. Now you're going to put that into another mole ratio to find out how much KNO3 is going to be produced, or it's going to needed to completely decompose that. So 1 mole of Na times 2 moles of KNO3 over 10 moles of Na gives you 0.2 moles of KNO3. So you're going to need 0.2 moles of KNO3 to to completely use up the sodium produced by 1 mole of Na and 3 decomposing. So the next question asks, how many liters of N2 are produced at standard temperature and pressure if 1 mole of sodium azide and 0.2 moles of potassium nitrate react? So this is pretty much asking what the total amount of liters of nitrogen here is going to be produced between each one. So first off, you're going to get that when 1 mole of sodium azide decomposes, you're going to set up a mole ratio of that to find the amount of nitrogen. So 1 mole of NaN3 is going to be multiplied by 3 moles of N2 over 2 moles of NaN3 to give you 1.5 moles of nitrogen. N2. And then you're going to set up another one for KNO3. So if 0.2 moles of KNO3 react, then that means for every 2 moles of KNO3, there's 1 mole of N2. So you're going to get 0.1 moles of N2, because it's going to be 0.2 times 0.5, which is 0.1. And then you're going to add 1.5 and 0.1 to give 1.6 moles of N2. That is down here. I'm sorry if you couldn't see this part before, but there's that work. And then now you have this. And then you're going to set that up into finding your liters. So 1.6 moles of nitrogen times 22.4, since that's the standard amount of liters in 1 mole, over 1 mole of nitrogen, and that's going to give you 35.84 liters of nitrogen, or N2. Now for the answer to the second question, which is to speculate how pressure is affected by heat and the amount of moles. So basically, the more moles of nitrogen that are going to be inside the bag, the higher the pressure, because there's going to be more of it inside of it, which is going to mean that it's more compact into a small space. And then temperature affects the pressure, because if you increase the temperature, you increase kinetic energy, which means that everything's bouncing around, so everything's going to be pretty much more compact in tight space, since everything's expanding in a small amount of space. So that is how temperature is affecting it, and everything I've said can be the same, but vice versa. So less temperature, less pressure, less moles, less pressure. So that is the videotape discussion on stoichiometry, and I'm sorry if you heard my little siblings in the background. And for my stuffed nose, I can't do anything about that. It's allergy season.